Hi, I'm Manfred Schwarz from Austria, and this is the third part of SpectroCalc2 tutorial. It's about the post-processing up to the final spectrum. If you remember at the end of the second part of this tutorial, after saving the calibration spectrum, the post-processing starts automatically. However, you can also start it by clicking at Open 1D Spectra and Project for post-processing. You find the result of your previous calibrated spectrum under the folder SpecCalc. You can see the summarized spectrum and all single spectra. In my case, I want only to work with the summarized one. Basically, the post-processing UI allows you to work top-down and left to right. It is not necessary to use all functions. It depends on what you need for your project. If you want to work with more spectra, click on Load Spectra. A very important function is the correction of instrument response. Each setup has its own characteristics that affects the shape of continuum. The best way to determine the response shape of your instruments is to create a spectrum of a well-known reference star with few absorption lines. The reference star should be near your project object and should be exposed in the same part of the night. Calculate with this function the instrument's response and store it for later processing in your project. In this case, click on Load Response. Often you have no chance to expose a reference star. For that situation, you can search for an existing reference spectrum of the same object or for the same type of object. Click on Load Reference. The first time it takes time to download the database of SpectroCalc2. Next time it is locally stored and you can access it immediately. There are three types of data pools. However, you can define your own. LOD is a very good library of high-resolution spectra from the Observatory of Haute-Provence. There are only few spectra delivered with SpectroCalc. You are welcome to download your desired reference spectrum from this page. LowRes is a low-resolution library for different star types. And the MILES database is a high-resolution library with a lot of objects. I use for my VV a reference from LOD. In the graphic window are four curves: the original spectrum, the reference star spectrum, the calculated instrument response curve, and the corrected spectrum. With aided spectrum fit, the graphic window shows the original spectrum and the calculated response curve. By changing the number of points, the editable resolution is changing. With Edit Reference Fit, the graphic window shows the reference spectrum and for this the calculated response curve. If the resolution of the reference is similar to the resolution of the spectrum, like in this example, you should use the same number of points. Let us go back to the spectrum. We do not want to use the emission line of H alpha for the correction, because this line is not stable in highness and in the shape. You can cut it by clicking on Cut Lines and define the left and right border. Now you can correct each desired point of the grid manually. Select the point marker, click on it and hold down the mouse button. Move it to the desired position and release the mouse button. You can only move in Y direction. For small corrections, it is necessary to zoom in. Do the same with the reference spectrum. Go back to show result. The brown line shows the instrument response curve. If you do not want to correct it in such a detail, you can overlay a polynomial function. You see, in this example, there is only a small change in the result. I use it here without the polynomial overlay. The complete setup for the instrument response can be saved for future spectra processings. Next time you can load it. However, you should visible control if the corrections are okay, and if not, you can change the cut areas or the problem points. Apply the correction. The turquoise color of the button signals that you have done this correction. For some projects, it is necessary to remove the complete continuum independent of the instrument response. This function is very similar to the previous explained one, but without a reference spectrum. You can define the shape of the continuum. You can cut lines, you can move shape points, and you can apply a polynomial function. Please be careful with this function. I do not need it here, so I cancel it. The next step is the normalization. There are several ways to do this. Enter the beginning and the end wavelength and press Normalize Continuum. With M, you can define the area by mouse click. With P, a parameter editor opens. Enter the area. Press Add. The value is now shown in the right list. It is also possible to store the value to use it for future processing of this project. If you are working in a team on a project, this value should be predefined. I have it already stored for my VV-SAFE. It is also possible to define more than one areas. In this case, all values are averaged. The values appears in green to signal that you have more than one areas defined. I turn it back to the predefined value for my project. For the crop function, there are similar ways as for the normalize function. Enter the crop area and press Crop the spectrum, or define the crop area with the mouse. With the parameter window, you can also define the area. You can save it, and you can use already stored areas. For an M star, it is very hard to find an area for signal to noise calculation. You can enter directly the area You can define more than one areas which are averaged. You see, this value is not really representative. Or you can define the area with the mouse. The parameters for the equivalent width can be entered by the same methods as described before. It is also possible to define more than one areas, which are averaged. In my case, I use the predefined value for this project. The best header definitions are necessary to store your spectrum in the best database. Anyway, these are important data and you should enter it. Some of the parameters are taken from the FITS header. The object data can also be downloaded from Simbart. Sometime you have to try it again to get the data. You can store it for your next processing. In addition, you can reload it if you have already stored it. The location of observation can be entered and stored. Next time, you can reload it. The observer dates can also be stored and reloaded. A correction of the atmospheric telluric lines is not possible on an M star. I recommend looking into the manual if you need this function. It is a very flexible tool where you can correct each single telluric separately if it is necessary. The heliocentric correction value can be calculated. Now it is entered in the FITS header. If you want to apply it to your spectrum, press Apply HC. In the FITS header, it is marked as Applied. Sometimes it could be necessary to shift the spectrum in the x-axis a little bit. Please look at the manual for this function. For documentation, you can add a text. Define the color and the size. It can set to bold. The title can be generated automatically from the FITS header. If you select it, you can change the size and the color. In addition, a complete legend can be generated automatically. If you want to change the text position, select it and click on the new position. You can also define vertical lines as markers. Here I define the both flux values of the V and R component of the H-alpha emission. If you are finished, save the spectrum and the complete project. Let us close the spectrum and reopen it. You see all documentation we made before. In the folder of the result, there are two files. One project file for SpectroCalc2 and the FITS file with the spectrum. If both are available, SpectroCalc opens additional to the spectrum the project file. At least I want to show you 3 log files. This was generated in the first processing step, 2D to 1D processing. You see the steps we made in the first part of this tutorial. This contains the calibration data. And this is the post-processing information. Please view also the other parts of this tutorial. You find the download link for SpectroCalc2 in the comments to this video. Thank you for watching and success with your data reduction with SpectroCalc2. Ciao and Servus.